Hi, our capstone title is A Smart House with Mobile House Monitoring Application, and our group name are San Vijian,
Aaron, Tok Changwen.
yeah, and let us proceed to the demonstration of our capstone. So this is all the hardware that we have built for our capstone project. So let us proceed to the first hardware, which is the Raspberry Pi. This is the CCTV, and this is the Raspberry Pi, the microprocessor for our CCTV, since it is located at a delocalized location. So this is why we use a different microprocessor. And followed by this hardware. So this is a modified socket. It can be used as a normal socket or a relay control socket. Followed by this is the air quality sensor, the MQ135 gas sensor, MQ2 sensor, a temperature and humidity sensor, and luminosity sensor, water level sensor, sound sensor, PIR, ultrasonic sensor, and lastly, the behind part of it. This antenna is used to extend the range of our user availability sensor, and this is the Ethernet port for the TCP connection. This is the switch to determine the manual or the automatic mode of the socket, and this is the power supply for the whole system. So one power supply is needed to power up the Arduino, the sockets, and everything inside it. And now we have explored the exterior part. Let us begin the interior exploration. This is the internal layout of it and the wiring between the sensors and the microprocessors. This is the energy sensor. This is the user availability sensor. This is the Ethernet shield for connection. Below it is the PCB board, and underneath the PCB board is the Arduino Mega that we have built under it. And all this wiring are protected by the rubber to prevent short circuit, and that's all from our hardware. So this is the Android phone application that we have built for this capstone project. So by clicking the setting, you proceed into this screen and you can key in the IP address of the server and the CCTV. So by keying in the IP, you click save. And also the pin code. If the pin code is correct, you can press login to proceed into the second page of the apps. So this second page will collect all the parameters harvested from the sensor and display on here. So let us begin with the CCTV. So by clicking the CCTV, you can see this is the image generated from the CCTV. And yes, these are the functions that are available for the CCTV. And now we can proceed into the LPG sensor. So as we bring in the LPG sample, this value changes as the LPG concentration increases. And after we remove the sample, these values will drop back to 0. And that's all from the LPG sensor. And now we proceed into the light. So since our light bulb is connected through this energy sensor, it can measure the energy used by the light bulb. So in this situation, it uses a 90 watt. So this light bulb is not only provide the light, it also gives the temperature rise to the temperature sensor. So as you can see in this temperature column, the temperature is continuously rising, and if the light bulb is near to it. So after it passed through the 30 degrees Celsius, the background color changes to yellow. This indicates a dangerous level. And under normal situation, the luminosity is 200 something. And if we bring in the light sample, the luminosity will increase to a value of 1000 something. And that's all from our light sensor and the temperature sensor. Now we proceed into the water level sensor. Under normal condition, the water level is displayed as 0. And if we dip the water level sensor into the water sample, it will show the output of 1. And that's all for the water level sensor. And now I would like to invite my teammates to wave at the PIR sensor. So if you are waving at the PIR sensor, you can see this motion column will produce an 1 as output. And now we proceed into the gadget, a user available gadget. This gadget will allow the system to know whether that the user is staying in the home or not. So by switching on this gadget, this user available column will change to 1. So this indicates the user has reached home. And after we switch off the gadget, the user will become 0 after some time. And that's all from these sensors. And now I would like to pass on to Aaron to explain on the control mechanism of it.
Now I will talk about the control mechanism that our project has. So now we are at a manual control, that is, we are not controlled by our Arduino. I will set it into automatic, which will give Arduino access to control our electrical circuit. It is controlled by a digital relay, which will be able to cut off or supply the voltage for our circuit. So now how we will test it is, we will see that if a certain light intensity or a certain lux is exceeded, which in this case we have set to be 300 lux. If 300 lux is exceeded, then our digital relay will cut in and our light supply will be cut off. So let's test this. So now our luminosity is around 80 plus. So as you see, it increases over 300. The light bulb actually turns off. And when it returns back to a value, then the light comes on back. So this is about our control mechanism. Thank you.
And that's all for our Android GUI.